Alright, we're going to learn two important tests today, the integral test and the p-series test. So this test is just going to tell us whether an infinite series converges or diverges. It's not going to allow us to find the sum or anything like that. So we're looking for a few things here. First of all, is it positive and decreasing? So when you look here, it looks okay. So this is a sub 1, a sub 2, a sub 3, a sub 4. So if you look, you notice that we're adding 2 each time to the denominator. Right now I'm just focused on the denominator. The numerator doesn't appear to be changing or anything. So when we have a common difference like that, that means that that's a linear relationship. So we can think about 2 times n. So the n is the subscript here, so that's 1, 2. So that would be 2, 2, 4, 6, 8. And if you compare that to this, you can see that that's plus 1. So we have the sum of 1 over 2n plus 1. All right. This is positive and decreasing. We're determining that just kind of by looking at the numbers there. So what we want to do is compare that to f of x. So we're going to let f of x be 1 over 2n plus 1, and then we're going to integrate that so that's going to be from 1 to infinity . Alright, so this is an improper integral from 7.8. So we're going to take the limit as b approaches infinity of the integral from 1 to b. And then we're also going to do a u substitution on this. So u is going to be 2x plus 1, and du is going to be 2dx. And so we're going to have 1/2 du equals dx. Alright. So if we switch that up, that's going to be limit. Let me write the integral over again. So 1/2, and then that's going to be du. That's going to be u. So that's going to give us 1/2 the natural log, and then we can substitute that back in. So that would be 2x plus 1 from 1 to b. So we want the limit b approaches infinity of 1/2 natural log of 2b plus 1 minus the natural log of 3 . So that's going to be 1/2 times the natural log of infinity, which is infinity, minus 1/2 the natural log of 3, which is going to be infinity. So therefore, diverges by the integral test. Alright, so let's try that again. So this is always going to be positive. We're plugging in 1, 2, 3, so that's positive. This is just 1 over e to the n, so there's no way that's ever going to come down, so it's positive. So the question is it decreasing? So to find out if it's decreasing, so it's positive, decreasing, question mark. So if we take the derivative and we switch it to x, so the derivative of that would be e to the u. Okay, so we're switching those to x's to compare it to the function. So that's going to be the product rule. So the derivative of x would be 1, so that would be e to the negative x squared, and then plus x times e to the u times du. Okay, so we can factor out e to the negative x squared. That's going to be 1 minus 2x squared. Okay, and if we think about that, this is always going to be positive. If we're plugging in numbers here, x equals 1, this will be negative, and then this, so that is less than 0 for x equals greater than or equal to 1, which means f prime of x is less than 0, so we are decreasing. Alright, so we're positive and decreasing, so we want to use the integral test here. So we're going to integrate from 1 to infinity of x e to the negative x squared dx. So we're going to use a u substitution on that, and we're going to let and so once when we get to parts that you know how to do, you should pause the video and do those parts. So right now we're just doing a u substitution integral, so that would be something you ought to be able to do yourself. Pause the video, do that, compare. So this is going to be negative 2x dx. We have an x dx right there, so we need to divide by negative 2 there. So we also have this improper integral again. So we need to take the limit as b approaches infinity. So I don't want to switch it to u's, and I don't want to have to think of the limits of integration there. So I'm going to just switch it back as I go. So I see that that's going to give us the negative 1/2. And then here, this would all be e to the u, du. So we integrate e to the u, we get e to the u. And then I would put that back in. So we would have that, and then this would be 1 to b. Okay. So if we plug those in, it's going to be negative 1/2 e to the negative b squared minus, this would be 1. Now, that would have been 1 over e to the b squared. And if that's going towards infinity, then that's going to go to 0. So that would be 0 plus e over. This would have been 1 over e. So when we distribute that, that would be plus 1 over 2e. Alright, so since that converges to a specific number, we can say that this converges by the integral test. All right. So just looking at that, hopefully you realize that that's going to be positive and decreasing because we're going to keep enlarging the denominator, numerator staying 1. So that's good. So another improper integral. So the limit as b approaches infinity, the integral is going to be from 2 to infinity. And we have, let's kind of separate this. We'll have 1 over the natural log of x times 1 over x. Okay? So this is a nice little move here. If we let u be the natural log of x, then du is 1 over x dx. So that would be that part. So that's nice. So this would be 1 over u, and the integral of 1 over u is the natural log of u. So we'd have the natural log of u, which is the natural log of x. And that's from 2 to b. Yeah, I should put a b up there also. Okay, so we're looking at the limit as b approaches infinity, natural log of b minus natural log of 2. So if we plug infinity in there, we're going to have infinity minus that, which is going to be infinity, so it diverges by the integral test. Alright, so we want to look at the integral here. We're going to do a few things. So I'm going to factor out that 8. We're taking the limit as b approaches infinity. We're going to go from 1 to b. Arctan x 1 plus x squared. Alright, so over here I'm going to let u be the arctan. So du is going to be 1 over 1 plus x squared. So that works out pretty nicely. Now, when we swap that out, we're going to, in this case, also swap out the limits of integration. So if we plug 1 in for arctan here, arctan of 1 is pi over 4, and that's going to be arctan of b. And then this will be u du. Alright, so if we integrate that, it's going to be u squared and half u squared. Okay, and then we want to evaluate that from pi over 4 to the arctan of b. Now we can pull this 1/2 out with that 4. So we have the 4 there. Limit as b approaches infinity. Here we're going to have, if we plug that in there, we're going to have arctan squared of b minus arctan squared of pi over 4. Okay, so as b approaches infinity, the arctan of that's going to be pi over 2. So we're going to have pi over 2 squared minus pi over 4. This is not arctan. The arctan was just up here. This is just pi over 4. So that should have just been pi over 4 squared. Okay. So that's going to be pi squared over 4 minus pi squared over 16, which is going to be, multiply this by 4 over 4, so 4 pi squared minus 1 pi squared is 3 pi squared over 16 times 4, so that's going to be 3 pi squared. Reduce that over 4, so since that converges, we can say that this converges by the integral test. All right. Okay, so now we want to look at the p-series test. So if we look at that pattern, all right, so p-series follows this pattern here, 1 over something raised to the p power there. So if p equals 1, it's called a harmonic series. So if p is greater than 1, then this is going to converge. If p is in between 0 and 1, including 1, then it's going to diverge. So all we have to do is take this, adjust it so that it fits this pattern, and then check out the p, the value of p. And then based on these two things, we'll say what we want to say here. So this one, and this will be the p-series test. So that's just going to be 1 over n cubed. And so then you're just going to say p equals 3. P is the exponent of the denominator there. And 3 is greater than 1. And so this converges by the p-series test. And that's it. Alright, so if we try that again, that's going to be 1 over n to the 1/2. And 0, 1/2. That's over here. So that diverges by the P-series test. And over here, that's 1. 1 is in between there. Less roots are here. So that diverges. So this is nice. Quick. By the P-series test. It's important you memorize these tests. We're going to have more. So we have the infinite geometric series, and then we have the integral test and the P-series test. We're going to have a couple more, several more. Okay. So now we have to figure out what is going on here. So I'm going to be able to rewrite this as a sum, n equals 1 to infinity. And we need to figure out what's going on here. So if we look at this is the first term, this is the second term, third term, fourth term. As I compare that, it kind of is pretty clear that that's 2 squared times 2 to the 1/2. That's 3 squared times 3 to the 1/2, etc. We're just focused on the denominators right now. So that's n. So this is n. This is 1 squared times 1 to the 1/2, but that's just 1. So this is going to be 1 over n squared times n to the 1/2, which is 1 over n, add the exponents, that's going to be 5/2. So now we can see that P, 5/2, is greater than 1. So that's the P, the exponent down there. So this converges by the P-series test. All right, it's about that time. Have a good day.